Oh, okay, so today we're going to look at matrix operations. We're going to start with scalar multiplication, and then we'll look at adding matrices and subtracting matrices. Okay, so let's start with some vocabulary. What is it that makes two matrices equal? If we have matrix A and matrix B, how do we know if they're equal? Well, two matrices are equal if they have the same dimensions. They have to have the same number of rows and the same number of columns. But also, they need to have the same corresponding elements that are equal. So in other words, your first element in the first row has to be equal to the first element in the first row of both matrices. Okay, so let's take a look at an example and it'll be more straightforward. Now let's look and see what it is that an example of two equal matrices. We have matrix A right here, and we have matrix B right here. You can see they both have the same dimension. They both have 3 rows, 2 columns. 3 rows, 2 columns. So they both have a dimension 3 by 2. They have the same dimension, which is one of the things that needs to be true. The other thing that needs to be true is the corresponding elements need to be equal. So in other words, our first row, first column element, which is 1, needs to equal the same in the other matrix, first element, first row. So we have 1 is equal to 1. The second element in the first row is 8, and in matrix B, again, first row, second column is 8. It's almost like if you took this matrix and put it on top of this matrix, you would see that all the elements match up. So second row, first element is 0. Second row, first element is 0. Second row, second column is 2. Second row, second column is 2, etc. Last row is 3 and 5, and we have 3 and 5. So each corresponding element, so the elements in the same position, are equal. So because they have the same dimension and that the corresponding elements are equal, we can say that the two matrices are equal. Now we're going to look at scalar multiplication, and that just says that each element of a matrix is going to be multiplied by a constant, the same constant. So in other words, if we were going to multiply every element in matrix M by a constant K, and in this, when we talk about matrices, the constant is called a scalar, and we would write it just like with the same multiplication notation, K times M, constant K multiplied by matrix M. Now we're going to look at an example of scalar multiplication. We are going to work with matrix A, which is a 3 by 2, 3 rows, 2 columns, and it has elements 5, 2, 9, 7, 8, 0. And we are going to multiply it by the scalar or constant 3. So we're just going to take that 3 and we're going to multiply it to each element in the matrix. So instead of 5, we have 3 times 5. Instead of 2, we have 3 times 2. Instead of 9, we have 3 times 9, etc. So instead of 5, 2, 9, 7, 8, 0, we have 15, 6, 27, 21, 24, and 0. Okay? Something you want to notice with scalar multiplication is that the dimension of your original matrix and the dimension of your product, the resulting matrix from doing the scalar multiplication, will be the same. The dimensions will be the same for both matrices. Now let's look at matrix addition. So we're going to add 2 or more matrices together. Things to note: you can only add matrices that have the same dimensions, okay? And you want to add the corresponding elements of each matrix. So let's go ahead and look at an example. Now let's look at an example of matrix addition. We have matrix A right here and matrix B right here. Right away you want to notice that when we add matrix A and matrix B, they need to be the same dimension. Matrix A is a 3 by 2 and matrix B is a 3 by 2. 3 rows, 2 columns. We want to take the corresponding elements, so the, what's in the first row, first column, first row, first column, and we want to add them together. So A is 5, B is 11. The resulting matrix will be 5 plus 11. A is 2, B is 1. Resulting matrix will be 2 plus 1. Okay, so let me keep going. So the second row, first column is 9. Second row, first column is 10. Resulting matrix is 9 plus 10. All right, so we add matrix A plus matrix B. We add each element together, and we have a resulting matrix 16, 3, 9, 12, 11, 8. Another thing to notice, again, just like with the scalar multiplication, both matrices, the original matrix is 3 by 2. Actually, both original matrices are 3 by 2. The resulting matrix will also be 3 by 2, so the dimensions will be the same. Subtraction is exactly the same, except instead of adding, you subtract, right? So the matrices have to have the same dimension, and then you're going to subtract the corresponding elements. Same thing. We have matrix A, matrix B. We're going to subtract them. They both have the same dimensions, so we can subtract them. If they didn't have the same dimensions, we would not be able to add or subtract them. And again, we take the corresponding elements and subtract. First row, first column is 15 for A. First row, first column is 11 for B. So we're going to subtract 15 minus 11, which gives us 4. Okay, so for each element, that's what we're going to do. For instance, third row, second column is 0. Third row, second column is 8. The resulting matrix would be 0 minus 8, which is negative 8. You also want to notice, again, the beginning matrices have the same dimension, 3 by 2. So we have a 3 by 2 matrix. We're subtracting a 3 by 2 matrix, and our result is a 3 by 2 matrix. Okay? Okay, so that's what you're going to need for the first assignment. I'm going to start off with some worksheets so you can practice scalar addition and subtraction of matrices, and then we'll go back to that assignment looking back at the food company, and we're going to, instead of looking at the product requirements, we're going to look at sales requirements. Okay, good luck, and again, I'll be around and checking in, and if you have any questions, please let me know.